Hey everybody, good afternoon. You are in the Introduction to Kubernetes and Rancher class. My name is Adrian Goins. If this is not the class you meant to be in, if you thought you were like on a flight to Las Vegas or this was like a cooking class or something like that, that's cool. Hang out anyway, and you're gonna learn some cool stuff about Kubernetes. Anyway, that's me. I do stuff for Rancher. Officially, I'm the Director of Community and Evangelism, but I was a field engineer. I worked in product marketing. I make content. I do trainings. I do all sorts of stuff. And all of those means to contact me, well, you'll get a copy of the slides at the end. If you are a person who tweets, please tweet with the hashtag of Rancher Training and Rancher K8s, and that way other people can know that you're having a great time. We have a lot of stuff to go through today, and I always run late. So I make no promises that I'm not going to run late, even though every single time I start this class, I say I'm going to really try and end at the 90-minute mark. So we'll see. I got some intro stuff. We're going to install K3s. We're going to talk about Kubernetes and customize, and then we're going to install Rancher, and we'll go through a bunch of stuff with Rancher. And then if there are questions at the end, we will also stay and answer. But if you look in your GoToWebinar panel, you'll see the little questions thing. Ask questions as you think of them. That's also the place to tell me things like, hey, you're still muted, or hey, your hair is on fire. I don't know. I'll check that periodically, and I'll also stop periodically throughout the class and answer questions. I'm going to take this slide out. I think pretty much everybody who comes here knows that they're learning Kubernetes and knows that they should probably have basic container knowledge. But in all honesty, as long as you know what a container is, we don't do anything with Docker except like one command. There is a repository for today's class. Let me switch the slides news crawler thingy to that. You can check this out, and I literally copy paste from the README, and so you can follow along. We will be using K3s. So you'll need a node where you can run K3s. You can use K3D, but there's like some kludgy, hacky stuff you have to get. Whatever. It's K3s today. Rancher has tremendous documentation. You can find answers to pretty much everything you might want to know at rancher.com/docs. And we'll pop into there occasionally throughout the day, particularly when we get to the installing K3s and installing Rancher part, not the installing K3s part. But the installing Rancher part, I'll show you in the docs, the various options and so on and so forth. So when you have a question, that's the place that you should go first. It's cold today. It's winter. I live in South America. I live in the Central Valley of Chile, about 3.5 hours south of Santiago, in literally the middle of nowhere. I have two 4G connections. Usually they work fine. Sometimes they don't. I do like QoS prioritization with diffserv code. I do all sorts of stuff to get my packets out first above everything else. But once they leave my house, it's hard to say what's going to happen to them. Anyway, I have a cup of tea. When I mentioned earlier that I might send you to other resources, this is where I would send you. We've got Rancher Slack. So this is the Rancher users Slack. There's 19,800 people or something like that registered. There's thousands of people online and active in various channels at any time throughout the day. So if you have questions that you'd like to try and get answered now, Slack's the place to go. Find the channel, post it there, and somebody will try to help you out. If you would like to search for questions that people have asked in the past, and or if you want to post a question that has more life than Slack, where it rolls off the top of the screen, the forums are the place to go. They're both excellent resources. Use them both. Myself and other Rancher engineers are in there. Is that actually the correct way to say that? Other Rancher engineers and I are frequently in there helping people out, so you'll find us there. We do get people in this class who want to learn Kubernetes and who don't actually know anything about Rancher. So if you'll give me just a couple minutes of your time, I'd like to explain who we are, what we do, what we're out to accomplish in the world, and why I feel that you're in the right place today. There are two key pillars of a successful Kubernetes strategy. Pillar number one is a certified Kubernetes distribution, and pillar number two is centralized management. Now, Rancher has solutions at both of these layers, pillars, but you don't have to use our solutions to be successful. As long as you use some certified Kubernetes distribution, and as long as you have a centralized management platform that can hit these key points, your Kubernetes experience will be successful. But what fun is it to talk about that without saying Rancher is amazing? For certified Kubernetes distributions, we have two. One of them is RKE, the Rancher Kubernetes engine. This takes all of Kubernetes and bundles it into Docker containers in a true microservices form. This reduces the host dependencies for Kubernetes. If you install Kubernetes via other means, you have to provision stuff on the host, you have to install the cluster and bootstrap it, then you have to install all the networking, and then you have to do all of this stuff. With RKE, you can do your provisioning via any means whatsoever, as long as you end up with a supported version of Docker on the host. We will take over from there and we will give you a full Kubernetes distribution. You can literally go from nothing to Kubernetes in less than 10 minutes. We also have K3s. K3s is our super lightweight Kubernetes distribution, and it is designed for resource-constrained environments like IoT and the edge. It runs all of the Kubernetes components in 512 megabytes of RAM, which means you can run it on things like a Raspberry Pi and still have lots of RAM left over for your actual workloads. And even though it's designed for edge and IoT, it works great in the data center. It's the Kubernetes distribution that I run pretty much everywhere, and it's what we'll be using in class today. We also encourage you to use hosted Kubernetes solutions like EKS, AKS, and GKE. Rancher's product, the second layer that we'll talk about in a second, works great with all of them. And we list these three, but we also work well with Alibaba Cloud and DigitalOcean. And hosted Kubernetes is a great way to start, because when you're starting out with Kubernetes, you really don't want to be in the business of managing the control plane. You can get to that later on. At the second pillar, you need something that gives, basically that does the heavy lifting of managing Kubernetes, so that you're free of the cognitive load of doing all that stuff and can and can instead focus on doing the stuff that you need to do. So Rancher is our flagship product. It's designed for deploying and managing Kubernetes clusters in any provider anywhere in the world, and it's a multi-cluster management solution. So a Rancher server installation can manage, I mean, you need a large server installation if you're going to do thousands or tens of thousands of clusters, but it's designed to manage multiple clusters with it's designed to manage multiple clusters, and it gives you simplified cluster operations and infrastructure management. So provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized audits. For security policy and user management, it allows you to automate processes and apply a consistent set of user access and security policies for all of your clusters. I'll show you that when we get into the Rancher portion at the end. And then for shared tools and services, it provides a rich ecosystem catalog of services. Keep checking the questions panel over here. A rich ecosystem catalog of services for building, deploying, and scaling containerized applications. And that includes app packaging, CI/CD, logging, monitoring, and service mesh. And there you go. Once you've got those things, you can put whatever you want at the top of it, and it will be successful. I already told you about K3s. Super lightweight. It's different from non-production solutions. It's designed to be a single node or multi-node Kubernetes solution for running in production. Other solutions like Minikube, K8s, and Kind are designed for development environments. K3s also works great for development environments, but it's optimized for production environments like I said, IoT, edge, or even data center. Our instructions for installing it have you SSH into the host and run some commands that actually do the installation for you. But Alex Ellis created a tool called Ketchup, which does that over SSH so that you can actually install K3s on other nodes from your local machine. And that's what we're going to do right now. I have here in my house a node that we'll be using for the K3s installation. We simply need to run ketchup install, give it the IP address, tell it what user we want to SSH in as, and tell it what version of K3s we want to install. Ketchup, with each Ketchup release, it's defaulted to a specific release of K3s, but they move at a different pace. So if there's a newer version of K3s that you want to install, in fact, well, yeah, we'll just do 1.17.7. There's actually newer versions. There's 1.18, but we'll go with this. So if you want to install a different version of K3s, you just tell it what version to install. This tool will SSH out, bring down K3s if it's not already on the box, fire it up, install the systemd services, wait for it to be running, and then bring back the kubectl config file that we will use to communicate with the cluster. I told you in the non-slide sharing portion that RKE will install a Kubernetes cluster in less than 10 minutes. You just saw K3s will install a Kubernetes cluster in less than 1 minute. We need to point the kubeconfig environment variable at the location of the kubeconfig file, which by default is going to be in your current working directory if you did the install with K3s. This is for the fish shell. If you use bash, it's going to be something more like export kubeconfig equals something like that. Whatever you need to do to point the variable at the file. And then anytime you start out with a new cluster or you've changed your kubeconfig environment variable, you want to immediately run kubectl get nodes. And that just demonstrates that you're connected to the right cluster. When you start managing multiple clusters, it's easy to be pointed at the wrong one. And if you start applying things to the wrong cluster, well, bad stuff happens. So always check and make sure you're pointed at the right one. And now we're ready to go. We have a Kubernetes cluster. By the end of today's class, you will know everything that you need to know about the basic components that Kubernetes assembles into an application. And that is derived from these things: pods, replica sets, deployments, config maps, services, and ingresses. With this understanding, you will be able to go and launch and manage and understand your own applications inside of Kubernetes. There are other things. There's persistent storage. There's lots of other stuff that goes on, secrets and things like that, that we don't cover in today's class. But once you understand these components, you'll be able to learn about stateful sets or learn about persistent volumes or learn about secrets, because they all come back to what you're learning here today. We'll start with a pod. A pod is the smallest thing that you can deploy in a Kubernetes cluster. Expand this window over here so that, oh, GoToWebinar, why are you so lame? I really don't like GoToWebinar. It's like their interface is whatever. Okay, so I can't expand the questions panel. So a pod, smallest unit that can be deployed in a Kubernetes cluster. A pod simply takes one or more containers and logically associates them together with shared network space, storage, and some other stuff that's not important for today's class. They're scheduled together onto the same host, and it enables you to follow the best practice of having a container do one thing. If you've ever deployed a container like that uses, Apache and fastCGI for PHP or something like that, those structures, they want to talk on localhost. Apache wants to hit the fastCGI server on localhost. And if you're doing that with multiple containers, it's hard. If you're just using Docker, it becomes much easier to bundle them together, and then you find yourself doing things like running supervise or systemd or stuff inside your container, and it's just not the way you're supposed to do it. So by using a pod, which is just a logical representation, you can now, it becomes easy for you to follow the best practice of have a container, do one thing and one thing only, and they can still talk to each other. Here's a sample of a pod where you've got a file puller container that retrieves content from some CMS system. It saves it to a disk. Then you have a web server container that pulls content from the disk and serves it out to consumers. This is a fine example of a pod with multiple containers, but together they provide some unit of functionality. And that's important. When you need more horsepower in your application, you're going to scale up the number of pods that are doing the thing that is the bottleneck. So when you need more web servers, you probably don't need more database servers. So you wouldn't put a web server pod, a web server container and a database, a MySQL container in the same pod. That would be a terrible architecture. I thought I had something more to say about that, but I don't. That's pretty much it. Everything in Kubernetes happens via YAML. Vinod, you're asking if the session is being recorded. Yes, the session is being recorded. That scrolls across the bottom occasionally. At the end of this, you will get a copy of the slides and a link to the YouTube video. It takes me about 24 hours to process it and get it up to YouTube and stuff. So look for an email about that tomorrow. Everything in Kubernetes is written in YAML. Nobody wakes up in the morning and says, I want to write lots of YAML today. So don't be alarmed as we're going through the class today and think that you have to remember all of this stuff. You don't. You just have to understand what it is so that you can go and look at examples, or you can copy paste stuff, or you can, so that you can build these things. And in Kubernetes, there are a dozen ways to do every single thing. So throughout today, I will also show you lots of different ways to do the same thing so that you understand what the possibilities are, and you in turn can choose what's best for you. This is a manifest for a pod. You have 4 top-level keys: API version, kind, metadata, and spec. API version tells Kubernetes where in its API it can find information about how to create the thing you're asking it to create. That's the pod, kind. Metadata, we talk about it a little bit. And spec is the definition of the thing. For the pod spec, you have a key for containers, underneath which is a list of 1 or more container definitions. At a minimum, you need the name and the image, but there's lots of other stuff in there that you can override. In our example, we are overriding the command to have it echo hello Kubernetes, sleep for 1 second, and then exit. We're going to jump over and run this. And while I do that, I want you to ask yourself, what's going to happen when the pod exits? You apply manifests to the cluster by using kubectl apply. You then, in this case, specify -f because we are going to apply a file, and then that's the location of the file. It's in the pod directory, and it's called pod.yaml. And it's exactly the same thing that I just showed you. In fact, if you don't believe me, look, there it is. Now we can watch this with kubectl get pods. And this tells us that it's running. If we want to watch that continuously, we can pass it -w, and it will continue to update when there's a state change. And you see that there was a state change. It went from running, it actually went to completed, and then it went to crash loop back off. And in a moment, you'll see that it's running, you'll see that it's completed, and then you'll see that it goes into crash loop back off again. Unless you tell Kubernetes that the thing is going to run and then exit, Kubernetes assumes that it's going to run and stay running. So when it exits, Kubernetes restarts it, and it exited. Kubernetes restarted it, and it exited. Kubernetes said, okay, well, hold on. Obviously, there's something wrong with you, and you're not running. So I don't know why. I don't know if you're waiting for something that's not there yet, like a cache or a database, or if you just have issues. So I'm just going to wait a couple of seconds. Okay, I'll restart you now. Oh, you exited again. Okay, clearly you need more time. So we're going to wait 4 seconds. And after 4 seconds, it restarts it and it crashes. It waits 8 seconds. It waits 16 seconds. It continues to increase that timer all the way up to 10 minutes between restarts. Then after 10 minutes, it starts it over again. That's a really long time. I think the total number of that is something like 27 hours or something obnoxious like that, where by that time, hopefully by then a person has figured out that there's a problem and has come along and fixed it. But if not, at least Kubernetes isn't consuming resources on the cluster trying to start this thing that clearly doesn't want to run. We will delete our pod by saying kubectl delete and specifying the name of the thing. It's the pod myapp-pod. We could have typed pod. Kubectl allows you to have abbreviations for things as well. And as you progress through your Kubernetes adventures, you will come up with your own aliases because you're going to get really tired of typing the same commands over and over and over again. And in fact, you will notice that I use shortcuts like KGNO. And when I'm running this class, I actually have another utility that expands my shortcuts into the full command so that you can see what the full command is. What we just did is fine. And when you're starting out, you're going to do a lot of it. But from the beginning, I want you to think about how to do things in a declarative and repeatable way. If you've done anything with infrastructure as code, any type of provisioning, any type of configuration management, you're familiar with tools like Terraform and Ansible and Puppet and Chef and so on and so forth. There was nothing really good for Kubernetes until somebody created a tool called Kustomize. Kustomize allows you to put templates under, well, it allows you to, first of all, to template out your Kubernetes manifests, and then you can put those templates into source control. And, well, it makes life a lot easier. Imagine, for example, that I make a bunch of changes to the cluster, and then I close my laptop and I go on vacation. And I'm on a sailboat in the middle of the ocean, and nobody can find me, and the cluster crashes. My colleagues have no idea what I did. They don't know. So they're left in a state where they don't know how to get the cluster back to the state that it was in before. GitOps is a workflow or a methodology or a religion practically that solves this problem by saying put everything into a Git repository and never apply changes directly to the cluster. Always apply changes to the repository where they go through validation and a CI process, and then they get applied to the cluster automatically by some machine program thing. So people aren't doing it. Now, if I'm on a boat in the middle of the ocean and the cluster crashes, my colleagues can just rebuild the cluster from the Git repo, and life is good. Kustomize was baked into kubectl back in version 1.14. You can learn more about it at kustomize.io. And for the rest of today, I will also show you how to do things with Kustomize, not only because it's important that you know and start thinking about how to do these things from the beginning. It's really hard to retrain bad behavior later on, but also because it makes it a lot easier for you to follow along with me if you have the repo checked out. You are never going to make pods directly because pods by themselves, while they're important, they don't give you any interface for managing or interacting with them. So you don't worry about pods. You let Kubernetes worry about pods. And instead, you create things that create pods. First is a replica set, which honestly, you're never going to create replica sets either. You're going to create deployments, which we talk about next, but you need to know that a deployment creates a replica set and a replica set creates a pod. Replica sets introduce state management. Kubernetes understands two states, the actual state and the desired state. In this example, the desired state is 12 replicas. The actual state is also 12 replicas. Kubernetes is happy. But if we lose one of those hosts, ooh, now we're in trouble. The actual state is 8. The desired state is more fingers than what I have. So there's a problem. Kubernetes says, okay, that's cool. I'm on it. I'm on it. And it does whatever it needs to do to reconcile those two states. In this case, it launches 4 more replicas on the remaining 2 nodes, and we're back to 12 and 12. And Kubernetes is once again happy. That's what it does. That's its sole purpose in the universe. And we, as operators or developers or whatever, the people who talk to the cluster, we never tell Kubernetes what to do. We tell it the desired state. And we can set up a structure, a framework, a set of guidelines on how it might make decisions to reconcile those two states. But if you find yourself saying, launch this pod on this host, then the architecture of your system is too limited. You instead want to say, launch this pod. And if you need that pod on that host because it has fast SSD disks or it's cheaper or whatever, there are ways to label and use selectors so that Kubernetes can decide that that host is the place for that pod. And that's important because if that host goes away, you want Kubernetes to put that pod somewhere else or not, but you need to set up those rules. So that's state management in the sense of Kubernetes. But you're never going to create replica sets. Instead, you're going to create deployments. There used to be a thing called a replication controller. Technically, there still is. Nobody uses it. We use the deployment controller. And this introduces controllers. Deployment controller creates, anyone? See all of you raising your hands? Deployments, right. Replication controller creates, not replications, replica sets. Ingress controller doesn't create ingresses, but it works with ingresses. Everything in Kubernetes is created by some kind of a controller. Deployments are for stateless applications, and this is different from what I was talking about a second ago. This is stateful versus stateless. HTTP is a stateless application. It doesn't matter from one request to the next. The web server doesn't know who you are. The web server doesn't care who you are. You just made a request and it gives it back to you. Your traffic can land on a different pod and it's fine. You can delete this pod and start that pod and it's fine. If it doesn't matter, you have a stateless application. If it does matter, well, that's a different story. Databases, you have a primary and two replicas. Well, it matters who the primary is. It matters what its storage is, what its name is, what its address is, that it comes up first, that the replicas can find it. If you have something that matters, you have a stateful application. And in Kubernetes, those are handled by stateful sets. There are also daemon sets, which start one pod on every node. So if you have 3 nodes, you get 3 pods. If you add a 4th node, poof, it automatically gets a pod of its own. There are also jobs, which are more like the thing we launched at the beginning. A job runs and then exits and Kubernetes doesn't restart it. And then there are cron jobs, which allow you to schedule jobs to start according to intervals or times, or it's just like cron. For today, we only talk about deployments because that's where everybody starts. And in fact, when Kubernetes first came out, that's all that there was. Kubernetes was originally written for stateless applications. One of the things that you can do with a deployment is you can change the version. You can also roll things back. So we've got version 1.0 of our application and 1.1 comes out. So we tell Kubernetes, hey, the desired state is 1.1. Kubernetes says, okay, and it starts a rolling update. In this example, it has launched 2 new pods, and then it deletes 2 pods, and then it launches 2 more, and it deletes 2 more, and a moment later, we have the application running on version 1.1. If there's a problem, we can roll this back. And there's a bunch of other stuff you can do with deployments like scaling and things like that. Let's create a deployment running Nginx 1.16 Alpine. We tell it, hey, go create a deployment. And Kubernetes says, okay. And it created a deployment for us. Now at the moment, it's not ready, but while it's bringing that up, we can see the replica set, and then we can see the pod. And you'll see that there's a correlation between their names. Deployment, and then the replica set is Nginx dash something, and then the pods are Nginx dash the same thing as the replica set dash a 5-character identifier for each pod. This is probably running by now, and it is. Congratulations, you have a deployment. Let's delete it. And instead, well, let's show you a different way to do this. What if you wanted to edit the manifest before it was applied to the cluster? Or what if you just wanted to save it and then edit it because you don't want to have to create deployments from scratch? Well, you can do everything that you were just doing, but you can pass it dry run equals client and -o YAML. And this will create the manifest that it would have applied to the cluster, but instead of applying it to the cluster, it shows it to us. And we can save it to a file and we can go through and we can edit it and we can do whatever we want with it. Great, let's save it to a file. And with it saved, let's go look at that directory. In this directory, we have deployment.yaml, we have service.yaml, we talk about services later, and we have a new file called customization.yaml. This is what customize will look at when you tell kubectl use customize to deploy things. And it's pretty simple. You've got a resources section that says, hey, go do whatever is in these 2 files. And then you have a config map generator, which is not required, but we're using a config map today, that says create a config map called index from the contents of these files. And if we look at that file, you'll see that it's just an HTML file. We talk about config maps later on as well. We apply this by saying kubectl apply, and this time -k for customize, and we point it at a directory with a customization.yaml file. And it created a bunch of services for us. Workloads, resources. It created a bunch of resources for us. So we can see kubectl deploy, kubectl get deploy. We have our nginx deployment. We also have a service, and we have a config map. If we look at the pod, kubectl get pods just shows us the pod. We can also say kubectl get pod, and then we can pass it the name of the pod, and we can say -o YAML. And it will now reach out to the cluster, fetch the YAML for that particular thing, and show it to us. So if there's anything running in a Kubernetes cluster, you can bring it down and look at it, save it to a file, use it to build new things. But this is the definition of, it's the definition of the thing. It's like, looking at a person and the cluster returning, okay, they're made of bones and muscle and blood and a liver and a stomach and a brain. And you're like, okay, that's fine. But what kind of a person are they? If you want to look at an object from how Kubernetes sees the object, you use a command called kubectl describe. If we say kubectl describe pod and whatever the name of the pod is, it brings back another block of information, but this is how Kubernetes sees it. And there's lots of stuff in here. In fact, there's things very directly related to what you saw in the YAML itself, but also stuff related to like its state. What is it? It's ready, it's initialized, it's, I just totally clicked on the wrong thing. And I totally lost my mouse. This happens sometimes. There we go. Yeah, so state-related things, stuff like that. But down at the bottom, there's a cool thing for events. These are a list of events, the list of everything that's happened to this resource since it was born into the cluster. You can see that it was assigned to a node, the image already existed, it was created, and the container was started. If there's ever anything wrong with a workload inside of Kubernetes, you want to go and look at kubectl describe and look at the events to get some troubleshooting information. Let's scale this. If we take kubectl scale, the deployment nginx, and we tell it how many replicas we want, Kubernetes goes out and does what we asked. Now we have 3 of them. That's wonderful. Let's upgrade it. Oops. kubectl set image on the nginx deployment. So deploy/nginx is the name of the resource. And even though there's only one container, we select to tell it the name of the container that we care about. In this case, that's the container called nginx. And we're going to upgrade it to 1.17 Alpine. And Kubernetes will go off and it will do this for us. You can watch a rollout happen with kubectl rollout status, and then you point it at the deployment. I know for a fact that we could wait for the entire rest of class, and this is never going to change. But let's pretend that we don't know that. And we're like, this is taking a long time. I wonder what could be wrong. You begin troubleshooting. Troubleshooting always begins with kubectl get pods. Oh, we have an error message. Okay. But note that even though we have an error message, the original 3 pods of our application are running. Customers are still on the site. People are still buying stuff. Our boss isn't angry. We're not going to get fired. We have the time to troubleshoot this and figure out what's going wrong. How do we do it? kubectl describe. The containers aren't running yet. So we can't look at the output of kubectl logs because there's no container to be spitting out logs. Logs come from the application running inside of the container, but the resource exists. So we can look at it from the Kubernetes perspective. We run kubectl describe. We jump down to the events section, and we see here that there's an error message, and it tells us that it can't find the image because I spelled it wrong. I do this every week. You think that I would figure out that alpine is spelled, I'm kidding. I do it every week, but okay, you get the joke. So how do we undo this? kubectl rollout undo. If the rollout had completed, this would actually roll it back, but since it never completed, it just nukes the stuff that it was in the middle of trying to do, and we're just up and running with our original 3 containers. Okay. You can look at what Kustomize is going to create for you by using Kustomize build and pointing it at the same directory where the customization.yaml file is. This will create for you the resources that it is going to apply to the cluster. Great. Another way to learn what it's going to do. This is a really good preliminary step for Kustomize because if you have an error in your customization files or in your manifest or whatever, it will fail and it will tell you. So you know that your manifest is broken before you try and apply it to a cluster. Let's instead pretend that we're doing something GitOpsy. We can edit our deployment.yaml. We can come down here to this image section down near the bottom, and we can change this from 116 to 117. And now we can commit this to a repository, and then it'll go through CI/CD testing, and then it'll get applied to the cluster. And you'll see that the config map was unchanged, the service was unchanged, but Kustomize knows that the deployment was changed, and so it updated that. The rollout is already almost through. It's in the process of terminating old replicas. This will update again in a second, and boom, it has rolled out. We look at kubectl get pods, you'll see that, well, we killed off, we manually set it to 3 replicas. I forgot to keep that, so it actually killed off 2 of the replicas in the process of doing the upgrade because it did what we told it to do. Okay, let's just delete all that stuff. And let's revert the deployment to the original one. The original one that I have in here actually uses the config map and has some other stuff because so far I've shown you how to apply things and an intro to Kustomize, and you're probably wondering, why would I use Kustomize when it just seems like more work than just doing it the other way? And that's exactly the question that you should be asking right now. The reason is because I have 2 directories here, base and overlay, and we're not actually supposed to be using the base directory. Inside of the overlay directory, I have 2 other directories, staging and production. If we look at the customization.yaml file in the staging directory, you can start to see how this is going to work. Everything will get a prefix of staging dash. Everything will get a label of environment staging. It will start with the base directory that we were just in, and then it's going to patch those files with these 2 files in this directory. It will then generate its own config map from the file in this directory. And in this directory, it says hello from staging. The other one said hello from nowhere. If we look at the patches, you'll see that it's going to change from 116 Alpine to 117 Alpine. And if you look at the replica count, you'll see that it's just going to run 1 replica. So that enforces 1 replica. If we go over to production, well, it's slightly different. Everything gets a prod label, environment production, but the rest is the same. It's going to use the base, it's going to patch image and replica count, and it's going to generate a config map that says hello from production. It will run 3 replicas, and it will run 1.16 Alpine because production is a little bit more conservative than staging. kubectl apply-k staging and production. And now from that one base environment that we were playing with in the beginning, we have created 2 other environments, production and staging. If we look at our pods, you will see that we have 1 staging Nginx pod and 3 prod Nginx pods. And I can show you the rest of the stuff, services and things like that, but we need to keep moving. Now you can start to imagine how you could have a base set of templates and just override the things that need to be changed in a development environment or a staging environment or a production environment. And it reduces the likelihood of human error as you're deploying these things out across your cluster. I showed you the 2 config maps, and I want to explain what they are, and then we'll look at them in a little bit more detail when we get into the services section next. If you've ever deployed, well, heck, an Nginx container, it comes with nginx.conf, but it's the default, and it is guaranteed to not do what you need it to do. So how do you fix that? Do you roll your own container and stick your own configuration file in it? Okay, sure, you could, but then you also have to update that when the upstream container changes, or every time you make a configuration change, you got to roll a new container and push it to a registry and deploy it over here. No. Do you mount an image? You can mount a volume in there with your own Nginx configuration. You could do that with like NFS. That's totally viable. But now you have another thing that can go wrong or another thing that can break. So it's still not a very good solution. Kubernetes solves this with config maps. And a config map allows you to override data in the container at runtime. Config maps are simply key value pairs. So they have a data section that has key and value. And the value can be a string, a number, or a multi-line thing like the HTML files that you saw. These appear in the container as either environment variables, where the key is the variable name and the value is the value. You can have it override individual files, where the key is the file name and the contents are the contents. Or you can have it override complete directories, where the directory gets 1 file for every key and the contents are the contents. Cool thing about config maps is that when you change the config map, it's updated in place in the container. So if your application is smart enough to detect configuration changes and refresh, you don't ever have to restart your applications. There are 2 camps on whether or not that's a good idea. One camp says, yes, it's a wonderful idea. It's less work for us. The camp that favors the infrastructure as code GitOps methodology says no, because it introduces the possibility that somebody could make a change to the running state of the container, of the pod, without that being reflected in the Git repo. And that's a valid concern. So by default, Kustomize will create a new config map, update the deployment, and restart all of the pods with the new deployment information. This is a much safer and secure way to make sure that the running state of the cluster is reflected in the manifests, but it does mean that when you change the config map, your stuff's going to restart. If you would rather that it not restart, you can tell Kustomize, don't do that, and it'll just update stuff in place, which is the default for how Kubernetes works. Which one you choose is entirely up to you. It's not to say that one is better than the other, it's whatever works for you. So we have stuff that's running, but we can't talk to it. You could hit pods directly on their IP addresses within the cluster, but you don't know that that IP is always going to be attached to that pod. You don't know that that pod's always going to exist. It could get rescheduled, the host could go down, lots of things can go wrong. It's a dangerous world inside of a Kubernetes cluster. Pods die all the time. Instead, you need what's called a service. A service exposes your workload inside or outside of the cluster. It has a stable DNS name and a stable IP address, and that's what you use to communicate with the pods. It keeps track of the pods that it cares about and whether they're in a ready state or not, and it's just a layer 4 load balancer. Traffic lands on it and it gets round robined across the pods. There are 3 types of services. Each one contains the types that came before it. Cluster IP service, it's the base one, that creates a service that's only accessible inside of the cluster. You have a DNS name and an IP address, and it's in the cluster. That's useful if you have a service in front of a set of pods that are consumed by other pods inside the cluster. Memcache or something like that, where you don't actually need to communicate with it from outside the cluster. Super. Then there's a node port service, which first creates a cluster IP service. Then it opens a high port on every node in the cluster. That port is randomly chosen from the range between 30,000 and 32767. Traffic lands on the port, gets routed to the cluster IP service, gets routed to the pods. And services don't really exist. They're logical things that exist as a bunch of IP tables rules. Next is a load balancer service. If your cluster is in a cloud provider and it knows it's in a cloud provider and you've done all of the magic incantations to tell it how to communicate with the cloud provider, then when you create a load balancer service, Kubernetes first creates a cluster IP service, then it opens up the high ports, and then it reaches out over the cloud provider's API and it configures a cloud load balancer. It configures that load balancer with the hosts and the ports and everything, and it maintains that configuration forever. So if you add nodes or remove nodes, it automatically updates the load balancer config for you. Traffic lands on the load balancer, gets routed to the port, gets routed to the cluster IP service, gets routed to the pods. Node port services are pretty much exclusively used for external load balancers, either a load balancer that you configure yourself or a cloud load balancer that Kubernetes configures for you. If you operate in a bare metal environment or any place where you can do layer 2 ARP and multiple IP addresses, you can use a tool called MetalLB, and there's another one called Porter that I haven't looked at, but MetalLB I'm very familiar with. And this will give you services of type load balancer on a bare metal cluster. And the way it works is you assign it a block of addresses like a DHCP server, and when it hears a request for a load balancer service, it grabs one of those addresses, assigns it to the interface, and begins ARPing for it at layer 2, saying, hey, this address is over here. Traffic lands on that address, and then it gets routed, and all the rest of it happens the way that it works. MetalLB will also work over BGP. So if you have a BGP fabric and you want to do route announcements into BGP for load balancer services on your bare metal cluster, MetalLB will do that for you as well. Super cool project. Services look like this. They're layer 4 load balancers. They're not intelligent. They don't make decisions. They just receive traffic, send it to a place. Hooray. Wondering if I actually have, yeah. So let's go look at the services really quick that we created. Before we start talking about ingresses, I got ahead of myself. I was very confused. You'll see here that we have, ignore the Kubernetes service. That's just the default service that exists as part of the cluster. But you'll see that we have 2 services, and they're both node port services, and they show a high port here. So if we were to curl my K3s node on port 31211, you see it says hello from staging. And if we were to hit port 31496, you see that it says hello from production. And that's it. It's not rocket science. You just hit the port, you get whatever is behind it. You can specify which port to use within that node port range if you want, or you can just let Kubernetes assign it and then you do it. You do your stuff from there. You're never going to go to somebody though and say, hey, I'm at example.com:31635. So what do you do? Load balancer services, while they're neat, they're a one-to-one relation between a service on the cluster and a cloud load balancer. Those things cost money. If you have a Kubernetes cluster that's running hundreds or thousands of websites, you don't need hundreds or thousands of cloud load balancers at $20 a month. That's just, no. We solved this problem already in normal web servers with name-based virtual hosting, and Kubernetes solves it with a similar thing called an ingress. An ingress is a configuration request to Kubernetes that says, hey, when you receive traffic for this host on this path, it's all about HTTP. When you receive traffic for this host on this path, send it to this service on this port. and that's it. Ingresses are served by a thing called an ingress controller. An ingress controller hears your request for an ingress to be created when you submit it to the Kubernetes API, and it configures itself to do what you asked it to do. They're layer 7 load balancers, usually served by, well, Nginx is the most popular one, but there's also HA proxy, there's traffic, there are API gateways, there are hybrid things, there's service mesh. There are lots of things that deliver ingress functionality. Whichever one you use is up to you. K3s ships by default. Most Kubernetes clusters use the Nginx ingress controller. But like I said, there's lots of them. Play with them, decide which one has the features that you want, and that's fine. They all understand the ingress request. And they are essentially layer 7 load balancers. They do make decisions. Because they need to look at the packet stream, they need to understand it. So they are designed for HTTP workloads or HTTP-like workloads. So REST APIs, HTTP and stuff like that, but you can't use HTTPS or MQTT or MySQL or anything that it's not going to understand. Most ingress controllers will still let you punch through a layer 4 port, which it will pass directly through to a service without looking at it. So you would use that for any of your non-HTTP workloads if you're still going to run them through the ingress controller. An ingress resource manifest looks like this. And actually, I need to take a step back and I need to talk about metadata. You see that we have metadata here, but this doesn't give a really good definition of it. Let's look at the services really quick. I meant to talk about this and I didn't. No. This is our original deployment. API version, kind, metadata, and spec. And if you notice in the spec section, there's a section called template. And everything that's under template looks a lot like the pod definition that we were looking at in the beginning. And that's because it is. Even though there's a replica set that gets created in between, ultimately the final object that a deployment creates is a pod. Metadata, no, metadata is metadata. The two most common keys that you will encounter there are labels and annotations. Labels are arbitrary key value pairs that you can set. They mean nothing, but you can use them for selectors. You should define whatever labels are necessary to allow you to uniquely identify or group things together. So in this case, we have a label of app is Nginx. Now the deployment creates a replica set. The replica set creates a bunch of pods. How does the replica set know what pods it's supposed to manage? That happens here. The replica set says you manage everything, while the replica set is told you manage everything that has the label of app is Nginx. And conveniently, our pods have the label of app is Nginx. So that's how it knows. Lots of things happen in Kubernetes based on labels and selectors. Things find what they're supposed, because IPs change, names change, all of that stuff is ephemeral. You can create an arbitrary number of objects with the same label, and then you can assign something to babysit them. All dogs that are white, all pods with this label, all cats that meow at the G flat, whatever. And then it's also good to collect things into groups. So our deployment, nothing cares about our deployment, but we still know that this deployment is responsible for the Nginx app. Services work the same way. You see here that the service has, labels, but then down here it has a selector. So it is going to route traffic to any pod that has the label of app is Nginx. And what's cool about Kustomize is that because we told Kustomize that everything's going to get the environment staging label, it not only updated all of the objects, but it updated all of the selectors. So even though our staging environment and our production environment have pods with the label of app is Nginx, if we look at the actual deployment running out in Kubernetes, you will see that Kustomize updated it for us to say that the deployment cares about things that have not just the label app Nginx, but also the label environment production. So that's how those two environments get separated with the services and everything else. Back over to ingresses. You see here that we're bringing traffic in. It'll be recognized if it goes for this host on this path, and it's going to be sent to the Nginx service on port 80. Easy enough. Annotations are a more advanced subject, but what they allow you to do is specify modifications to configuration on an object by object basis. In the case of an ingress, if we were running the Nginx ingress controller, it would know to modify its config for just this particular server block with whatever additional commands we had in here. Since we're running traffic, traffic will ignore this. So they allow you to have something make dynamic adjustments for just a specific use case in which it might be running. You don't need to worry about them for a while. If we look at our customization.yaml file in this directory, you'll see that we're going to prefix everything with dev. It's going to be a dev environment. We're going to use the ingress.yaml file here. We'll use our same base directory, but we're going to patch it with this service patch, which is basically the same thing. It just changes our service type from node port to cluster IP. If we apply this, well, we just got a whole bunch of stuff created. You'll see now that we have a dev Nginx environment. We have a service called dev Nginx, and notice that it is a cluster IP service. It's right there. So there's no high port. And we now have an ingress, dev demo ingress, which is listening on our public IP, well, non-cluster IP, public in the sense that it's outside of the cluster, and it's going to respond to this host. So if we were to curl that host, we get the default config map. So here on our single node cluster, we have 3 environments running: a dev environment, a staging environment, and a production environment. Cluster IP service and 2 node port services, a bunch of pods, all happily coexisting in the same Kubernetes cluster. That's it. That's Kubernetes. That's all you need to know to get started doing stuff. So let's just really quick jump back to that slide that I had at the beginning and recap. Pod, smallest unit of deployment in a Kubernetes cluster. It's the base thing that does everything. Replica set babysits pods. Deployment babysits replica sets. You can just think of deployments launching pods, and that's totally fine. Config maps allow you to override information inside of a container with either environment variables, files, or entire directories of files. Services expose workloads inside or outside the cluster at layer 4. Ingresses front services at layer 7, and they do HTTP load balancing or optionally can do layer 4 pass-through on certain points. Congratulations. You know Kubernetes. Go forth into the world and build clusters and make lots of money. Do you know that the median salary right now for Kubernetes jobs is 147,000 US dollars? That's ridiculous. I have a friend of mine who's not sure if he should learn Kubernetes, and I was like, are you kidding? Like, how much money do you make right now? Go. It's great. It's like, it's the thing right now. There's so much demand. There's not enough supply for people who know this stuff. So the fact that you're here today says that you care about your future, and that is deserving of respect and applause. Very quickly, I will check the questions panel, and then we're going to move on to the Rancher stuff. Looks like we have no more. Oh, hang on, we got a couple questions. We got people, let's see, are you sharing your screen? Yeah, okay, and that's old. Okay, Vishal says, when I launch an EC2 machine using Rancher, I'm actually using RKE. That's correct. I'll talk about that in a second. Vinod says, is K3S a product of Rancher Labs or from CNCF? K3S is Rancher right now. It has not been donated to the CNCF. It is ours. But it's open source. Everything that Rancher does is 100% free and open source. So RKE, Rancher, all of it. It's not like there's a free version and a paid version. Rancher sells enterprise subscriptions to companies who want support, but 100% of the products themselves are free. Okay, that's it for questions. So let's go talk Rancher. My Rancher slide says Rancher time. Woohoo! That's it. So let's jump over to a browser. In the Rancher documentation, you will find information on Rancher 2.x, Rancher OS, RKE, and K3S. Don't worry about Rancher 1. We still have this documentation because we still have some people out there still running it, but everything now is going into Rancher 2, which is all about Kubernetes. Inside of the documentation, there's a section on installing Rancher, and it says that there are two ways that you can install Rancher. One is as a standalone Docker container, and that's only for lab environments, demonstrations, things like today, because it's fast, but it's not highly available, and there's no way to go from a configuration inside of the Docker version to an HA Rancher installation later on. The HA Rancher installation is installed into a Kubernetes cluster. So the instructions there have you set up a Kubernetes cluster, either RKE or K3S. That is HA. And then, well, if that is HA, then when you install Rancher into it, Rancher uses the highly available functionality of Kubernetes to itself become highly available. That's pretty much it. If you have an HA Kubernetes cluster, you install Rancher into it, you have HA Rancher. But because it's two completely different architectures, you can't lift your configuration from one and drop it into another. What you can do is bring up a single node Kubernetes cluster, which obviously is not HA, but with RKE, you can go from a 1-node cluster to a 3-node cluster on the fly. So you can scale it up later to become HA once you decide that Rancher is something that you want to continue to use in production. For today, we are just going to install it as a Docker container because it's fast. I have another node out here that will act as my server. And we will run docker run d for detash. Restart is unless stopped. Don't use restart always. Punch through port 80 and 443, and I like to bind mount a directory from the host. I use opt rancher to the persistent location inside of the container, which is varlib rancher. And then we will be running version 2.4.5 of the Rancher server. That takes just a minute to come up. All right, so it's not up yet. It will be any moment. By default, Rancher installs with self-signed certificates, but you can also use Let's Encrypt, or you can bring your own certificates. Wow, why is this taking so long? You can bring your own certificates from either from self-signed, from your own CA, or from an actual CA. There we go. So because we just went with the self-signed certs, we get the warning. That's fine. We'll accept it, and we are first presented with a screen that asks us to change our password. After this, we are asked to set the Rancher server URL. Now, this is important it's worth pausing here. This is the address that downstream clusters will reach back into to communicate with the Rancher server. The Rancher server communication goes in two different directions. Rancher server talks to the Kubernetes API over the Kubernetes API port, which is 6443. But there's also an agent installed in the Kubernetes cluster that reaches back to the Rancher server on this address, and it opens a WebSocket connection. It then keeps that open and does communication. You could use an IP here, but if that IP changes, your downstream clusters won't connect. And it's a nightmare to try and update this on a downstream cluster that's been disconnected. So it's much better to use an actual FQDN here and then point that to an IP. And then it's also important that this is actually accessible from whatever cluster is being launched. Here we have the global cluster screen. All of your clusters would appear here. We have none, so we will add one. We are presented with a number of different options. Down here at the bottom, we can spin up a hosted Kubernetes solution, EKS, AKS, GKE, and there's others that we could enable in the config. This will reach out, provision the cluster, and then install the Rancher agents and wire it back to the Rancher server. And it does full lifecycle management of all of the cluster resources. If you delete the cluster in Rancher, it gets deleted out in Amazon. We also have a number of infrastructure providers here and more that can be enabled. These are, who's the gentleman that asked? So Vishal, is it Vishal or Vishal? Vishal. Vishal asked if you get RKE. If you use the infrastructure provider, take EC2 for example. You say, I want 3 nodes of this size and they're going to be workers, and I want 3 nodes that are going to be a control plane, and go. Rancher reaches out over the cloud provider's API with the credentials that you give it, provisions the infrastructure, installs Docker on KE, of all of the resources for you. If you do your provisioning via any other means, Ansible, Puppet, Chef, Terraform, shell scripts, autoscaling groups, whatever, at the end of your provisioner, just make sure that you install a supported version of Docker. And if you select the custom option, we will give you a Docker run command that is unique to the cluster that you're building. You just put that in your provisioner, and it'll run that Docker run command, build out the cluster, and wire it back into Rancher. I actually prefer this method. I use autoscaling groups out in Amazon, and I have the Docker run command inside of the cloud init statement so that if I add another node with the ASG, it automatically joins the cluster and I don't have to worry about it. If you have Kubernetes clusters already running out there in the wild, you can import them. And you'll also use this for K3s. But Rancher treats K3s a little bit differently when importing it. You're given a couple of different kubectl apply commands. If your Rancher server uses real certificates, you can use this kubectl apply command here, but kubectl won't talk to something using self-signed certs. So we have to use the bottom one in our deployment here. So I will run this, and it will fetch the manifests and apply them to the cluster. And in a moment, the agents will be installed and this will show up as active. While we're waiting for that to happen, let me talk to you about the global level configuration that's available within Rancher. And I'm still going to try and end this with questions within the next 17 minutes. So if we do end up running long, this is being recorded. You will get a copy of the slides and a link to the video. You can come back and watch the rest of it later. But let's try and really want to finish on time. Global level configuration. You can add Helm charts here. So as you're adding applications into Rancher, you can do that from the UI by adding people's custom Helm catalogs, and you can configure these with scope for global, meaning they're available to all clusters, cluster, where they're available to one cluster, or project, where they're available to some namespaces inside of a cluster. If you have other providers that you want to enable for infrastructure or cluster, or if you have a Docker machine driver that you'd like to import, you can enable those here, and then they become active in the add cluster screen. The first thing you should do in an enterprise environment is plug Rancher into some backend identity provider. This will bring down the users and groups from that provider and make them available for role-based access control on all of the clusters that Rancher manages. You can also do it directly with users and groups right here in the UI, but this is super powerful when you have a lot of clusters managed by a lot of teams in a lot of different places, and you don't want to be in the business of managing access control and user policies and user credentials in 3 different providers and the cluster under somebody's desk, and figuring out when somebody leaves the organization, what did they have access to, and hoping that you eliminated their cluster rights before they come back and you have an Equifax on your hands. Instead, let's say you use Active Directory. So you point Rancher at Active Directory, you bring in all the teams, you assign them to all of the clusters, and people log into Rancher and they get a kubeconfig from Rancher, and Rancher becomes the authentication proxy, and they connect to the clusters through Rancher. Now, when somebody joins the organization, you just add them to the right group, and they get their access. And if they leave the organization, you just disable their account, and they lose all of their access. This is the #1 most powerful enterprise feature of Rancher. Same thing happens with pod security policies at a global level. You can make the changes here and apply them to all of the clusters. Less opportunity for human error. Still waiting for our cluster to finish importing. Oh, and it's done. Great. There are 2 projects that you get with every cluster by default. Kubernetes uses what are called namespaces to logically separate workloads. So you could have like a staging namespace and a production namespace, and you could have workloads running in each of them. And the namespace becomes the boundary for role-based access control in Kubernetes. If you want to restrict access to a namespace, well, you just configure the namespace. But what if you have hundreds of clusters and dozens of namespaces on each of them? You're back in the business of making a change in lots of different places. Rancher creates a logical thing called a project, which is like a namespace of namespaces, and that becomes the boundary for role-based access control. You apply access to the project, and it automatically propagates to all of the namespaces underneath it. System project contains system stuff for the Kubernetes cluster that you probably just shouldn't be playing around with. And the default project gets the default namespace, and you see that it already has all of the workloads that we already created. Let's jump back over and delete one of those from here so that I can reuse the ingress. So we'll just delete the dev environment, and you see that it went away there. Rancher is a real-time reflection of what's going on in the cluster. And even though we deployed all of this stuff from Customize, I just want to show you that you can edit it here and you can make the changes. And in fact, let's just go deploy something new. If I click deploy, let's say that I want to run a demo application. I want a scalable deployment of 3 pods. I could select a stateful set or a daemon set or a cron job, but I just want a 3-pod deployment. We're going to run Monachus Rancher demo. I know that this listens on port 8080. I want a cluster IP. I want to set an environment variable of cow color equals yellow. And I could make other changes here. I could enable a health check. In fact, let's just do that because that's fun. So we want to get / on port 8080. And that's a readiness check. If that returns anything other than a 200 or a 300, it'll fall out of the service and it won't receive traffic. We could do persistent storage. We can control how it gets scaled and upgraded. There was an advanced options link over there in the corner that I just clicked, which gives us a whole bunch of additional high-level deep configuration options for the workload. I'm not going to play with any of those. I just want to spin this up. You'll see that it's spinning it up. Rancher doesn't hide anything from me. I can come in here and actually view and edit all of the YAML directly if I so desired. Because I requested a service, it automatically created one for us there. And so even while that's spinning up, let's come over to the load balancing tab and say that we want to add an ingress. We'll call this demo. I want to reuse my host name. I want to pick the demo service, and I'll send / to it on port 8080. I don't have any SSL certificates or anything I need to add here. I'll just say save. Ingress is up. Come back over here. Workload is up. And if I click this little thing here, it will take me to the actual application. And here you can see in real time what happens with the load balancing of the traffic. That little green flag shows you which container our traffic is being routed against. And now imagine that this is an application for a client. And we get a call, and the client's like, we didn't realize our boss is allergic to the color yellow. He's freaking out. I'm like, that's cool. Calm down. Let's just update the application. So I'll click edit. I'll come back in here to the environment variable, and let's just change yellow to pink. Scroll down and say save. Kubernetes begins to do a rolling update of the application, just like we saw when we did it on the command line. And if we were to come out over here, you would see pink cows start coming in just a moment, and the yellow cows will start fading out, and that's a rolling update. You can already see that it's faster to do things in the Rancher UI, but it's not only faster, it's easier. Somebody with a basic understanding of container architecture and zero understanding of Kubernetes, maybe just the basic concepts, can start deploying real workloads and can start tying things together from within the UI. Where Rancher starts to get really powerful is when you look at additional applications that you can deploy. The package manager for Kubernetes is called Helm. You already know about package managers. You know, RPM, Yum, Yas, dpackage, emerge, whatever. Well, Helm is the same thing. Rather than me giving you a long README and saying, install this container and connect it to that and set these values and so on and so forth, people have packaged applications or groups of applications into things that you can launch. So for example, if we wanted to launch a Hadoop cluster, let's say that I'm a developer, sitting at my desk, working on an app, it needs to talk to Hadoop. I don't know anything about Hadoop. I mean, I know how to talk to it, but I don't know how to launch it. I don't know how to launch it in containers. I don't know how to launch it in Kubernetes. And more importantly, I don't care. That's not my job. My job is to build an app that talks to Hadoop. In a normal situation, you will get resistance from developers who are like, why are you making me learn something new? Why are you getting in the way of me doing the things I need to do? This isn't my job. But when you're using something like Rancher, the developer has access and he can come in and say, oh, you know what? I need a Hadoop cluster. Hey, look, there's Hadoop. Okay, here's a form that I can fill out. It's got some sane defaults in it. So I can say, okay, you know, I don't need persistent volume because I'm going to delete this in a little bit. I don't. Okay, so yeah, we'll expose it via the load balancer. That's cool. Automatically generate a host name. These values are then substituted into, look at all of those manifests that get created. So they're substituted into those manifests, and the developer can just click launch, which I'm not going to do here because my little node can't run a 5-node Hadoop cluster. But in about 10 minutes, it'll build a multi-node replicated Hadoop cluster and hand back an endpoint that the developer can just put into their app and get right back to work. 10 minutes. You will find that the people who depend on your Kubernetes cluster are more likely to use it when you make it easy for them to do so. But what else can we do here? In addition to launching workloads, there's a bunch of advanced level stuff that Rancher brings for what are called day 2 operations. These include things like alerting, logging. We can send logs out to any of these endpoints, and you can send them out via the cluster or via the project independently. The cluster might ship all of the container logs to Elasticsearch, but the devs in a particular project, well, they might use Splunk. Great, more power to you. Basic monitoring is included. You can attach advanced monitoring if you have a little more resources than what I have on this little node. And this installs Prometheus and Grafana, pre-installs a bunch of dashboards that show you information about the cluster as well as the workloads, and then enables all of the alerts at the cluster level for cluster level resources and at the project level for workload resources All you have to do is jump out to the global level and set your notifiers here of where you want those alerts to go. And notifiers can go to Slack, email, PagerDuty, WeChat, or arbitrary webhooks. Once those are set, attach them to the alerts, your cluster's telling you stuff. Backups are included for RKE clusters. Jump back out to the global level here. There's an integrated kubectl shell right here within the UI. Or here's that kube config I told you about. They copy this down to the clipboard, and now instead of connecting directly to the cluster, they're connecting through the Rancher UI, and you get all of that authentication enforcement happening as well. It includes, back into the project here, arbitrary catalogs, a basic pipeline system. If you don't have a CI/CD system already, you can just plug it into your existing repos and start having workloads deployed and updated directly from push and pull request. Horizontal pod auto scaling allows you to set parameters at which pods will be automatically scaled up. So for example, average pod CPU utilization is over 75%, add more pods. When it drops below, kill off those pods. It will deploy and manage Istio for you with full Istio configuration from within the Rancher UI. Secrets are just like config maps, but for secret data. And so there's a whole interface for that as well. Everything that Rancher does is designed to get you from I want to do something to actually being able to do that thing as quickly as possible. Kubernetes has a learning curve to really get good at it of about a year. And that's a year of really being in it every day, using it, screwing it up, and none of us have time for that. If you want to use Kubernetes and get the benefit of using Kubernetes such that you can go and learn the details of it on your own time as you need to, then Rancher is hands down the best tool to help you do that. Go to webinar, just told me something stupid, but it looks like it's back. Okay, let me check these questions. We got about 4 minutes left. Ratish says, is Rancher to manage cluster or make Kubernetes HA? Rancher deploys and manages Kubernetes clusters. So it doesn't make Kubernetes HA. You have to have, it can make a Kubernetes cluster for you that is HA and then manage it. Or you can launch your own HA Kubernetes cluster and bring that into Rancher. Guidance for using RKE in an air-gapped environment. Yes, we have an entire section in the Rancher documentation about installing Rancher and RKE in air-gapped environments. I don't know if I can highlight that so you can see it. So it's here in the Rancher docs. It's also down below in the setting up Kubernetes clusters in Rancher, and it's also in the RKE docs specifically for RKE. Rancher has Kafka Helm chart support. Yeah, totally. I mean, it's there. If we were to come back out to apps, and if I said launch, and if I typed Kafka, there you go. How does Rancher work together with GitOps? A lot of these features automatically apply the manifest to the cluster. Can we link the Rancher to the GitOps repo in some way? That's a question from Leandro. In Rancher 2.5, which is coming out in another 6 weeks or so, we will have a much better integration with GitOps. GitOps is relatively new. Rancher 2.4 came out in March, and it's only been since then that GitOps has really started to pick up speed. So we've built a whole GitOps structure into Rancher that you will be able to use. All right, that's it for the questions. Let me just wrap up my slides, and we all actually get to end on time, which is pretty exciting. If you like what you saw today and you want to know more, most of today is about Kubernetes. I do, less than half an hour on Rancher, but I created the Rancher Academy for you. It's about 5 hours of video. If you spend 3 to 5 hours a week, it'll take you 5 weeks to finish. It is deep, deep, deep dive into deploying Rancher and using Rancher to deploy and manage Kubernetes. It includes video instruction, demonstrations, and hands-on labs, and it ends in a certification that it's from us that says that you have passed the final exam and are certificated to go forth and deploy and manage Rancher in production. It's at academy.rancher.com. It's totally free. It's super popular. We have more than 1,000 people sign up for it on the first day. We have close to 7,000 people enrolled right now. It's only been around since the middle of May, and we've issued close to 1,000 certificates. You can't go wrong with the Rancher Academy. Remember that you can join Rancher users Slack. If you don't have an invitation, go to slack.rancher.io and you can get one and join for free. And there you will find a whole universe of people who are here to help you succeed. My name is Adrian Goins. If you like the way that I teach, I give this class, I teach lots of other stuff. I also create content for Rancher. So in fact, Rancher's YouTube channel is a tremendous place to find information about Rancher and Kubernetes. We have live stream office hours sessions. We have Kubernetes masterclasses about specific Kubernetes topics, often hosted with partners of ours like Sysdig and others. We do online meetups on specific deep dives into Rancher technology like Longhorn or K3s or really cool features. We have these trainings. There are thousands and thousands of hours of videos up here for you to watch and learn from. And then I also have a YouTube channel where I have content on Rancher, as well as content on other cloud native things. And I do a daily live stream every morning at 7:30 Eastern time for 30 minutes, where I present and talk about cloud native solutions that were announced the day before, or in case of Mondays, over the weekend. So I go through about 200 submissions a day, and I distill that down to about 10 items that I can talk about in half an hour. And they're all things that I would use myself. And I've been building internet infrastructure for 20 something years now. So it's useful, actionable information. And it's first thing in the morning, I'm a little tired, we're all drinking coffee. It's just a nice social little place to hang out. So I invite you to come and join. You can find my channel at adrian.goins.tv. And that is actually in the slide under the YouTube section. One last check of the questions panel. Sure, thank you very much. Sure gave me a really nice compliment, I appreciate that. And Srini asks, what are the prerequisites to attend the certification? Nothing. Well, actually, that's not true. You should have basic Kubernetes knowledge, but you don't need more than that. What you got out of this class is enough for you to go forth with the Academy training. That's it. Everything else, it focuses on Rancher, not on Kubernetes. So it's a deep dive into everything about Rancher, but it doesn't go into crazy Kubernetes stuff. It's about how to deploy and manage Kubernetes clusters and use Rancher to do backups and disaster recovery and various other things, so that what you have is a Kubernetes environment that you can use. You don't have to have a lot of Kubernetes skill to go through the Rancher portion of it. Kubernetes stuff is on you. All right, everyone, getting a lot of thank yous, no more questions. We're just 2 minutes over. I want to thank you for coming to this. I appreciate your time. I appreciate your attention. I am the Director of Community and Evangelism. You can find me on the Rancher user Slack. I'm Adrian. I am here to help you be successful. And so find me, let's talk. And you let me know what you need, and I'll do my best to get it for you. Have a great rest of your day, rest of your week. Have a safe weekend. We'll see you next time.